Hi everyone, myself N. Arun Kumar from SNS College of Technology in the Department of ECE. In this video, I am going to share about congestion control algorithms. Generally, the congestion has been happen based on the data traffic because if you want to share the data from source to destination node, we need to check the data first because whenever we need to transmit more number of data at the same time means it just overlap with each other or one some of the packets may not receive the destination. So these are all things we need to check. These are the data or make some traffic in the traffic in between the destination end. So need to check based on the data traffic. In congestion control, we try to avoid the traffic congestions. In quality service, we try to create an appropriate environment for the traffic so that before talking about congestion control and the quality of service, we will discuss about the data traffic itself. So generally, the data traffic has been happen based on the number of routers because router is the medium which is used to forward the information to the receiver based on the number of inputs received. Next one is if there happen any packet loss or congestions, then the graph has been executed based on the number of inputs received at the receiver side. Sometime the delay may be happen because of number of packet loss or high, so that the graph does not match with their destination. The output has also makes more number of congestions occur in the uh, in this graph. And next one is throughput. Throughput is number of input signals. Based on the number of input signals, we need to receive the output signal. Throughput also increase based on the number of packet losses happen. So congestion controls are divided into two types. First one is open loop and second one is closed loop. Open loop congestion controls are based on a retransmission policy, window policy, acknowledgement policy, discarding policy, admission policy. And whereas closed loop systems are based on back pressure, choke pocket, implicit and explicit signaling. Open loop congestion. So open loop is we can able to transmit or receive the data based on the number of times because retransmission policy is also mapped with each other so that we can transmit more number of time based on the number of packets. Next one is Windows policies are based on sliding window or go back and windows. Sliding window is we can able to send the particular data based on the number of data received, and go back and is based on number of datas based on sliding windows because sliding windows are used to select the data as a bit. For example, if n equal to 3 means it just forwarding the data by 3 by 3 if any errors occur in between the receiver side so that it can check the errors at the number of nodes so that it can make and avoid the data as a number of times number of nodes based on the selection so that it can just send the data number of 3 n equal to 3 values to the destination end. Discarding policy, the best data has been received and the packet loss or any congestion occurs so that the data has been lost and it cannot be forwarded to the receiver side. Admission policies. The admissions policies are based on quality of service mechanism because quality is the technique which is one of the main factor we will receive the data without any errors. Next one is router can deny the establishing a virtual circuit connections if there is a congestion in the network or if there is a possibility of future congestions. And next one is closed loop control congestion controls. Closed loop congestion control is it's a closed path because we don't want to extend the data level so that the closed level is only the data up to the feedback process so that once the data has lost at any end, we can't receive the original information at the receiver sides so that we need to check all the data once again. So in this method, back processor is we need to, if so for example, if the congestion occur on the third node means, then we have to check the previous node as well as the previous one, which kind of errors has been generated to the next node. So that the pressure has been generated to the next node, then we can check the proper connections on proper node. Then only we can able to send the data to the next node. Next one is choke pocket. So in this method is choke pocket, we can able to find the errors on the particular node. For example, if the errors occur in the third node means, then automatically just indicate to the source node so that it can make the third node as a new one, and then it can be transmit the information to the receiver side. Next one is implicit and explicit. Implicit means input signals, explicit means outside of the signal. If the signal is error in the input means, then automatically we can retransmit the data on the input side. Next one is explicit means it just the particular data or the data with your neighbor has been changed and then able to transmit the data to the next one. Backward and forward signaling. So because once if you are identifying any errors occur in the transmission, then automatically we can able to check the backward and forwarding process so that we can able to check the data's originality and the quality service of the particular data assessment. What are the key metrics for measuring the effectiveness of a congestion control mechanism? Such as, because throughput and packet losses are the main process of congestion control algorithm. We need to check this throughput and packet loss. Throughput refers the actual amount of data transmitted successfully over a network in a given period of time, usually measured in bits per second. Congestion leads to packet loss, especially when the network buffers are full. An effective congestion control algorithm should minimize the packet loss by managing the network load efficiently. So while processing the throughput and packet loss, we need to follow the above parameters for making a better efficiency. Thank you.